Okay, so if you still remember when I first introduced you the basic of area under graph, we talk about vertical area and we talk about whether area is positive or negative. So it all depends on whether the area is above the x-axis or below the x-axis. So this example will illustrate the idea of a positive area and negative area. So the first thing that goes into your head will be, you must be very sensitive to identifying a negative area. So in this situation, anything that is below the x-axis is considered negative. So this part is going to be the negative area. And then this part is supposed to be the positive area. So you must be able to identify this so that you can work with them separately. So another way, right, is, okay, if you observe the positive area, there are two sections. So we got this section. We also got this section. So you might want to label them for easier identification. So in this case, I label X, Y, Z. And the one that is labeled Y, I'm expecting it to be a negative. So now we have an idea, we got some parts that's positive, we got some parts that's negative. So it will be better to treat each part as it is. So for part A, finding the X coordinate will be very easy. The X coordinate is just the X intercept. So you just simply apply your concept of Y equal to 0. You should be able to get the subsequent X coordinate. So remember, the X coordinate is actually to form a vertical wall. But in this situation, the vertical wall is not so vertical that you can actually see, because it just happened that it just cut in this way. Otherwise, it's supposed to be a vertical wall, like I mentioned in the introduction video last week. It's supposed to be a two vertical wall. Okay, but in this situation, the wall doesn't look so vertical, but it does cut. Okay, so in the first place, right, the region X, so the region X has two vertical walls. The vertical wall is X equal to 0 and X equal to 2. So you should be integrating the equation of the curve. So can you see I integrate the X coordinate? Okay, I integrate the curve. So if you observe carefully, I integrate the curve. Okay, you look at each of the formula that I use. I'm using very basic formula. You add a power, divide by new power. So I integrate. So remember, when you do definite integral, you must integrate before you put in the 2 and 0. So it's a bit like top minus bottom. So some people may have some issue getting the 6 and 2/3. So if you got some issue getting the 6 and 2/3, I suggest you really write it out. So you really write it out. So this is the top. Top means you put in the X equal to 2 and you subtract, you put in X equal to 0. So if you are the kind who is very careless with your calculator, then I suggest you really work it out. Okay, so I'm expecting it to be positive and it's really positive. So for Y, okay, for Y, right, I'm expecting it to be negative. So if I got a vertical wall here, so I'm expecting it to be negative. That's why I put a negative outside. Okay, so it's better that you block it up. You block it up. Okay, I integrate. Okay, I forgot to put the 4/2. So by right, you should put in the 4/2. So you ignore the negative. You make sure you do the 4/2 first. So this one is how I get this. I get it from substituting 4. And how I get this part, right? I get it from substituting 2. You can punch calculator to see whether is it true or not. So the top minus the bottom. Okay, so top minus bottom. So if you do that, if you punch the inside, right? If you just punch this part, you are getting a negative. You are getting -1 and 1/3. And because you introduce a negative, that's why the area became positive. Okay, so if you just punch the top minus bottom, you get a negative value. So why is it a negative value? Because it's purely below the x-axis. That's why you kind of negate it away with an extra negative. Okay, so you must do it with the expectation that you already know that there is a negative area. So you go and find area Z. Area Z has a different wall. Area Z will have a different wall, x equal to 6 to x equal to 4. So these are the two walls that create area Z. So that means you will do your definite integral on 6, 4. You realize the integration doesn't change. The curve doesn't change. If you integrate, of course, it doesn't change. So the only thing that changes your values, your top and your bottom. So if you do the top minus bottom, in this case, right, you get a positive value, which is very expected because it's above the x-axis. So your job is to do them section by section so that you can isolate the negative area. So your job is to do them section by section so that you can isolate the negative area. Okay, and then you will add up your 3 area. So this is area X, area Y, area Z. So you just add them up. You should be adding positive area. You cannot be adding negative area. So that's how we get the total area under graph if there are some negative area and there are some positive area. Okay, so this is one of the most critical thing, identifying positive and negative area. So there will be question to test you whether you know how to filter positive and negative area.